So again, we just determined the coordinates of P where we assume that P was between A and B. But that's not the only situation that we could have had. In your book, for the most part, is just going to show this one. But I want us to think more deeply about this. I could absolutely have P not between A and B. Instead, I could have A between P and B. And so that's the situation that we're going to look at. So this is situation 2. Okay, think about if you had AB. AB. Now, we said that AB to AP is a 3-to-1 ratio, meaning that AB is 3 units or 3 times longer than AB. Well, if I went this direction, if I went a third of the distance, AP, you can think that this right here is 3 times shorter than this length. Okay, should have drew it a little bit straighter. Okay, and so we're going to do the same exact thing that we did before. Let's let P have coordinates x and y. A has coordinates 1, 2, and B has coordinates now -1, 4. And just like in the other one, there's 3 different similar triangle situations that you could use to obtain the points. We'll show just one of those. Okay, so we'll show one. So I'm going to draw the picture again. Okay, so I'm going to put here's A and here's B. So if this is 3 units long, this length right here is just 1 unit. So you got to think of this entire length as 4 units. This is 1/4 of this total length. This is 3/4 of this total length. Okay, so we have then a 3-to-1 ratio. Let me label the points here. A is 1, 2. P I'm calling x, y. And B is -1, 4. Okay, and so let's make some similar triangles here. So we have that. That's our bigger triangle. The coordinates of this point now has the x coordinate of B, but it has the height of y. Okay. And we can play with different coordinate systems that you have. I'm going to deal with 2 different triangles. Okay, I don't want to deal with the bigger one and then the smaller one. I want to deal with one triangle where I can get all the measurements for. So I'm going to deal with this triangle and relate that to this triangle. That was the third situation in the previous problem. Okay, and the reason why I'm doing that is that all the lengths of this triangle are known. It does involve x and y. Okay, so I've made a strategic choice to make the algebra a little bit simpler. So this length right here, okay, is going from x is 1 to x is -1. This length is still 2. And the length here starts off at 4, ends off at 2, so this length is 2. And that's the exact measurements we got in the bigger triangle that we had in the previous one. Okay, now the issues we got to determine is how much smaller is this triangle than this one. Now remember, this length, whatever this is 3 parts, and this is 1 part. There's a 3-to-1 ratio. This triangle is 3 times bigger than that ratio, or that triangle. So that means this length, okay, is a third smaller than 2. A third smaller than 2. Okay, so we could say 1/3 of 2 has to equal to, I'm going to deal with the y coordinate first. Okay, so if I do 1/3 of this, that would be this length. And this length is the difference of y coordinates, 2 minus y. And if we solve for this, add the y over and subtract over 2 minus 2/3, we get 4/3. Okay, so 4/3, so a little bit less than 2. And we're going to do the same thing for the x coordinate. This length is 2, and 1/3 of that, okay, it's going to give me this length, which is the x coordinate minus the x coordinate here, x minus 1. So adding that 1 over, you get x 1 plus 2/3, and that gives us 5/3. So the coordinates in this situation would be 5/3, 4/3. And that's how we can get the other situation where P is not in between those.